the back. And there's only 3 problems back there. And one of the reasons that I wanted to do these problems, is just to get you a little more comfortable with the notation. Do not be frightened by it. These are all concepts that you are comfortable with. So problem number 1. If you can't find your paper, would you just maybe take a picture of somebody else's so that you can look at it? But let's pay attention now and quit digging around for papers. We're on the back side of our homework sheet, the page that says extra notes. All right, so there are 3 tables here. State which table or tables could not represent discrete probability distributions. Okay, so take a look at table A. Does everything there look okay? Now, let me explain what it says. It says that whatever you're doing, the game you're playing, your probability of getting a 1 is 0.1. Your probability of getting a 2 is 0.2, 3 is 0.3, and 7 is 0.4. Is that okay? Could that happen? Yeah, I think that's okay. Isn't it? All right, let's look at the next one. The next one says, again, whatever game you're playing, the probability of getting a 1 is 0.1. The probability of getting a 2 is negative 0.2. Wait a minute. Can probability be negative? No. So that's a no. And the reason you're going to say is probabilities can't be negative. All right, what about C? You think C's okay? It's fine. Now, what could go wrong with a probability table? Well, what do you have to check on? Think of the problem we just did over here. What was the very last thing we did here? Why didn't I reduce these? Because they have to equal 1. So to be valid, your probabilities have to add up to 1. They can't be negative. None of the probabilities can be negative. And none of the probabilities can be bigger than 1, right? So as long as you meet all those qualifications, you're okay. Are you with me? I know it's Friday and you're so happy to be here. All right, Sarah researches multiple births in a clinic. She keeps a record over a period of years of the genders of triplets born there. There are 8 possible sequences of genders in a set of triplets. We actually did something similar to this. You could have boy, boy, boy. This is what they mean. So if you had triplets, they could all be boys. The first 2 could be a boy, and the last one's a girl. Boy, girl, or girl, boy, girl. Right? Oh, I think I missed one. Girl, boy, boy. And then girl, girl, boy.
Boy, girl, girl.
What?
Boy, girl, girl.
Boy, girl, girl.
And then girl, boy.
There they are. There are the 8 sequences. So you're in the delivery room having triplets, and they're born in order. You know, just like 3 of them just happen at once. You gotta have first one, then second one, then third one. And they can come out in any of these orders. This is called the sample space. There it is. These are all the sequences. Assuming that you have an equal chance of both, so the next one says the probability of male is the same as the probability of female, and it's 0.5. So we're making an assumption there. Construct the probability distribution table for the number of females born in a set of triplets. So your table, this is going to be the number of females, and then this is going to be the probability. Well, how many females can you have when you have triplets? You could have none, You can have 1, 2, or 3, right? So we're building a probability table just for the number of girls. All right. How many of these have no girls? So the probability is 1/8. This is just like what we did over there with the dice. How many of these have 1 girl? That one, that one, and that one. So 3 of them, so that would be 3/8. How many have 2 girls? That one, and that one. So that's another 3/8. And then there's one that has all girls.
Yeah.
Now, take a second. What's supposed to happen here? Do they add up to 1?
Yes.
That means you got it all. You've taken into account everything. And we're done. So now you can answer questions. So if your goal in life is to have triplets and have them all be girls, you have a 1/8 chance if you have triplets. First of all, you gotta have triplets. But if you have triplets, you have a 1/8 chance that they'll all be girls. Now, one more. Guys, stay with me. We have one more. We have our outcome and we have our probability. And they set it up for you. 5, 8, 9, 10, 11, 12. And the probabilities are 0.5, 0.05, 0.04, 0.1, 0.2. And they didn't tell you what that last one is. Can you figure that out? Yeah. Don't the probabilities have to add up to 1? So you can fill that in as long as they gave you all the rest of them. So we're going to 0.5, 0.05. Watch the decimal points, get them in the right spot. I think it's 0.11, but double check my arithmetic. Don't let the notation bother you. It's really, really easy. Okay, now, that's question A. You just figured out question A. It's find that probability. Find the probability of 12. You got it. B, find the probability of an answer in this interval. Now, what does this mean? You're more than 8, but less than or equal to 10. So more than 8 would be here, but less than or equal to 10. Aren't we talking about these columns right here? So we're going to add these probabilities because we have to be a 9 or a 10. So the answer is 0.14. Perfect. This means, this right here tells me I have to be a 9 or a 10. So I'm going to add those probabilities. All right. Find the probability. A is no more than 9. Now, what does that mean? No more than 9. It's this part right here, right? So what am I going to do with these numbers? I have to be a 5 or an 8 or a 9. So I'm going to add them up, and that is 0.59, Sam says. Find the probability of at least 10. Isn't that the other half? So what's that?
1.31.
Does that make sense? If this half was 0.59, does it make sense that that half would be 0.41? Sure, because it's got to add up to 1. What was that? At least 10. Okay, last one. What's the probability that A is greater than 8 Oh, I think that's something I don't wanna do, so I'm gonna change it. A is greater than 8 and A is less than or equal to 11, so I'm rewriting that problem. That vertical bar has a meaning, but we haven't discussed it. I'm not going to. So it's just A, we're gonna do A is greater than 8 and A is less than or equal to 11. So if we're greater than 8,
So 9, 10, and 11.
so this is what we're looking at, right? 9 or 10 or 11. So that would be point, is that 0.34? Now, does all that make a little bit of sense anyway?
Yes.
Do not let the notation confuse you. When you have the P out here in front, that means find the probability of that.